In this video lesson, we are discussing angle pair relationships.
You're going to learn about four different important angle pair relationships. We're going to be talking about vertical angles and applying the definition of vertical angles to solve for some missing angle measures, complementary angles, supplementary angles, as well as linear pairs. Our first angle pair relationship are vertical angles. Vertical angles are two angles formed by intersecting lines that share the same vertex and are congruent. So if we take a look, we actually have an example of two pair of vertical angles. So if we look at this diagram, we could say that angle COA, now remember we could also call that AOC, is vertical to angle BOD. Therefore, those two angles are congruent. Similarly, angle COB or BOC is congruent and vertical to angle AOD or DOA. So if you take a look again, let's just focus on one of these pair. Let's focus on this angle and this angle. If you take a look at those two angles, you can see that they share a vertex and then the angle measures themselves are congruent.
In this first example, we're going to use what we know about vertical angles to find the value of this variable y that's in our picture. We can later, when we learn about supplementary angles, find x, but for right now, we are just going to focus on finding the value of y. So we said the important thing to know about vertical angles is that they are congruent, meaning they have the same measure. So if I'm asking you to find y, and we're using vertical angles to do that, we want to first identify that this angle that measures 63 degrees is going to be vertical to this angle. So those are our vertical angles. We do have another pair of vertical angles, the unmarked angle at the top. That angle is going to be vertical to the angle at the bottom, but we're not using those right now because we don't have enough information using only vertical angles to solve for x. All right, so if we know that these angles are congruent, that means they have the same measure. So what that means is that the angle on the left, which we're going to say is y plus 23 degrees, that angle must be equal to 63 degrees. So when angles are congruent, they have the same measure. It's not really necessary to use the degree symbol in our equation. So this is a pretty simple algebraic equation. We are going to combine our like terms. So to get 23 to the other side, so our constant terms are together, we could subtract 23 from both sides. Therefore, y is isolated by itself on the left, and 63 minus 23 is 40. So in this problem, the value of y is 40. Now, remember, the angle itself is still 63 degrees. So when I ask you what the value of y is, you'll tell me it's 40. If I asked you for the measure of this entire angle, you would still tell me that that measure is 63 degrees. Our next important angle pair relationship are complementary angles. Now, this is probably a definition that you've heard of. So two angles whose measures have a sum of 90 degrees. Those are complementary angles. So if we look at two examples, what I want to be clear about is that they don't have to share the same vertex to be complementary. So in this example, over to the left, angle ABD, that angle, it's complementary to angle DBC. Now, normally, to know that it's complementary, right now you know because I'm telling you, but normally we would be looking for that right angle symbol or just some other information so that we could conclude that those two angles add up to 90 degrees. But this is also another pair of angles over here that are going to have a sum of 90 degrees. So they're still complementary even though they don't share a vertex. We're going to look at two examples of using complementary angle definitions to solve for a missing value or angle. In this example, you can see in our diagram that we are missing the value of x, but we know that those are complementary angles because we can see that that blue square there telling us that the big angle is going to be 90 degrees. So to find x, using the definition, we know that whatever x is, when we add 62 to that, we're going to have to get 90. So we said again, complementary angles have a sum, which means add, of 90 degrees. So now, in order to solve this, it's simple algebra here. We're just going to subtract 62 from both sides of our equation. And once we've done that, we have x isolated by itself on the left, and 90 minus 62 is 28. So we know that angle is 28 degrees.
Example 3 is a lot like example 2, except now we have some algebra. So again, we know that the two angles in this picture are complementary, and we know that because we can observe the symbol for a right angle here, that little square. That tells us that this larger angle is a right angle. Therefore, this ray that comes out creating two different angles is just separating two smaller angles that are complementary. So because they're complementary, again, going back to the definition of complementary angles, we said their sum is 90 degrees. So I can reason that 3x minus 15, when I add that to 2x plus 10, the sum of those two angles is 90. Now, they use parentheses in the diagram just because of the degree symbol on the outside, but we don't really need them for the algebra that we're going to do here. So we do want to next combine our like terms. I always start with our variable terms. So 3x plus 2x gives us 5x. And then we also want to combine our constant terms, but we need to be careful here because 15 was being subtracted. We're just going to think of that as a negative 15 and a positive 10. So when I combine negative 15 and positive 10, I'm left with negative 5. So I get 5x minus 5. All of that still equals 90. All right, so now it's a simple two-step equation. I know I'm using the reverse order of operations, so I'm going to add 5 first to both sides. When I do that, I now have 5x on the left, and 90 plus 5 is 95. Then I'm going to divide both sides by 5. And 95 divided by 5, I could really think of that. I know 100 divided by 5 is 20, so 95 is 1 less 5 than 20. So x is equal to 19. You're, of course, welcome to use a calculator as well.
Our last angle pair relationships are really similar, so I'm including them in the same slide. The supplementary angles in a linear pair. So let's look at these two definitions. Supplementary angles are going to be two angles whose measures have a sum of 180 degrees. So a lot like complementary angles, but they add up to 180. A linear pair are going to be two supplementary angles who share a vertex and a side and therefore form a line. So it's kind of a subtle difference. Let's look at these two pictures. Supplementary angles, again, if you're looking on the left, we can see this angle is 60 degrees, this angle is 120 degrees. So when you add 120, you get 180. So by definition, those angles are supplementary. They're not, however, a linear pair. A linear pair is going to be when we have two different sets of supplementary angles. So if we look here, angle LMK, it shares a vertex M and it shares the side MK. That angle is going to be supplementary to angle KMH. And because they share a side and a vertex, we call those a linear pair. So for example, let's say that angle KMH Let's say that's our 60-degree angle. We're just pretending. It looks like it's probably a little bigger than 60. If this angle were 60 degrees, this angle would then have to be 120 degrees. Now we know that they are a linear pair because L, M, H are 3 collinear points. Therefore, LH is a straight line.
In example 4, we're applying the definition of supplementary angles. I do want you to observe that not only are these angles supplementary, but they're a linear pair. And we know that because they have a common vertex and a common side. And remember, the side of an angle is a ray. Another way we know they're a linear pair is that because they're supplementary with a common vertex, their other two sides, so the two sides the angles don't share, make a straight line. That's what makes them a linear pair. All right, we're asked to find x. This is a pretty easy problem because we know the definition of supplementary angles is that their sum must equal 180. So therefore, the angle that is x, when we add that to the angle that is 130 degrees, that's its measure, that sum must be 180. Oops, sorry, it's hard to draw an 8 on here. So if we use our subtraction property of equality, we could, oops, I didn't really mean to make an equal sign there. We could, there we go, subtract 130 from each side, and we would be left with 50. So x is equal to 50 degrees. This supplementary angle problem in number 5, example 5, is a little more complex because we have algebra now instead of, or a little more complex algebra, I should say. Let's take a look. Again, we have a linear pair. We know they're supplementary, so I know that the angle that is measured with the expression 3x minus 20, that when I add that to x, when we combine those two angle measures, their sum must be 180. And again, we really don't need parentheses here since it's addition and subtraction. So just like we've done before, we want to combine our like terms. I always start with the variable terms. 3x plus x, remember the coefficient of x is 1. So 3x plus 1x is 4x. So we get 4x minus 20 equals 180. All right, now we just have a simple two-step equation. So we want to add 20 to both sides to eliminate our constant term. So we get that 4x is equal to 200. And then we want to divide both sides by 4. We know 20 divided by 4 is 5. Therefore, 200 divided by 4 is 50. So x is 50 degrees. And if we're thinking about that, that means our other angle must be 130 degrees. So again, those are supplementary.
You made it to the end of the lesson. Don't forget, I'm expecting to see all the examples and definitions in your notes, and you may always rewatch the video again if that's helpful to you.